Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Muhammad Farhan bin Nur Muhammad Nizam.
Assalamualaikum, my name is Mukmin Muwahhid bin Aidil.
Assalamualaikum, my name is Amar Redzuan bin Mokhtar.
I will be introducing what is the definition of tree. So a tree is an cyclic graph or graph that have no cycles. So in other words, it is a discrete structure that represents hierarchical relationships between individual elements. So a tree or general trees is defined as a non-empty finite set of elements called vertices or nodes having the property that each node can have minimum degree of 1 and maximum degree of n. Okay, so the main objective for us is to investigate and to improve understanding towards the pattern of the tree. So a tree in which a parent has no more than 2 children is called binary tree, and if there is a lot of tree graph, we call it forest. A leaf is a vertex that have no child, while a parent is a vertex that has child. So the vertex which is of 0 degree, it is called the root of the tree. Okay, so I've included a past year question, which is a question about Huffman code. It tells us to decode and to encode the word. So Huffman code is an efficient method of compressing data without losing any information. In computer science, information is encoded as bits. There is an algorithm for generating the Huffman code for a given message based on the frequencies of symbols in the particular message. We need to also understand the encoding and the decoding. Encoding is a mapping of an arbitrary A into the set of finite sequences, which is words, over some alphabet B, while the inverse mapping is called decoding. In other words, decoding is the process of turning communication into thoughts. Alright, let's move on to the decode. So first thing first, you will need to trace these words, by which is what is its bits, 1 or 0. Okay, just follow the flow like the arrow. Okay, and you will get S is 111 and is 110 T. So we determine the words based on the table. Okay, so here 000 it is E, 001 is A, and 01 is R. The next one is C, we get 111 is S, 000 is E, and 001 is A. So next is to encode the word nearest state. Okay, as usual, you refer to the table you just made, and you can see N, its binary number is 110, E is 00, A is 001, and yes, so on, and you will get the answer. Thoughts?
Assalamualaikum, my name is Muhammad Fitri, and I will show you a question about binary tree expression. So this is the example question. So what you need to do is, first choose a form of question before you construct a full binary tree. This form into this form, and second, it is very important to put the brackets properly because it helps you which one you need to construct or draw first. And you need to remember that one parent only has 2 child, right child and also left child. First, we put division symbol as a parent, and then we put symbol minus as a left child for division symbol, and then multiple symbol as a right child for division symbol, and then symbol of power as a left child for minus symbol, and then symbol of power also as a right child for minus symbol, and then we put plus symbol as a left child for symbol of power, and then we put A as a left child and B as a right child for symbol plus plus symbol, and then we put not of 2 as a right child for power of symbol, and then we put D as a left child and 3 not as a right child for symbol of power, and then we put symbol of power as a left child for multiple symbol, and then we put S as a left child and 4 as a right child for symbol of power, and then we put symbol of power as a right child for multiple symbol, and then we put Y as a left child for symbol of power, and then we put division symbol as a right child for symbol of power, and then we put 1 as a left child and not 2 as a right child for division symbol. So the second question asks you how to find height of the tree. So what you need to do is you need to make a line, and then you need to count starting with 0 from top to bottom, and then you will get 0, 1, 2, 3 and 4. So the answer is height of tree is 4. And third question, you need to find size of the tree, means that you need to count how many nodes in the tree. So if you count, you will get 19 nodes. So that is the answer. And the accident of node 4 means that it is just like you and your father, your grandfather. If you see the node 4, and then you will see accident for node 4 is symbol of power and multiple symbol and also division symbol. So that's all from me. Thank you.
Okay, now I would like to explain about logical implication and rules of equivalence. Logical implication is an argument from hypothesis to conclusion. Each argument must follow the laws of logic. In mathematics, a valid argument is an argument when the conclusion is true if all the premise is true. Next is rules of inference. Rules of inference is a method to determine the validity of an argument. We might use truth table to find the validity of the argument, but it can cost a lot of time. Thus, rules of inference is a much better way to validate the arguments.
So objective for chapter 5, the fundamental of logic. There are 3 objectives. The first one is to know that logic have a connection with our real life, and second involve how we think as logically in any situation, and last to enhance our skills in analyzing various kinds of arguments that will come across us elsewhere in the course of our lives.
So this is the problem statement. If Ahmad takes a walk, then it is not raining. If it is not raining, then Siti will go shopping. Siti does not go shopping. Therefore, I will give you 5 seconds to think about the answer. So, before we validate the arguments, we need to find the primary proposition first. So the first primary proposition is P is Ahmad takes a walk. Secondly, Q is equal to it is raining. Lastly, R is Siti go shopping. Then we need to find the premise for each argument. So if Ahmad takes a walk, then it is not raining. This is P implies not Q, and we will state that this is premise 1. Secondly, the argument is if it is not raining, then Siti will go shopping. This is not Q implies R. We will state this argument is premise 2. Lastly, the argument city does not go shopping is stated as not R. This is premise 3. Okay. Now I will show you how to validate the arguments. So first we must place premise 1 in row 1. Premise 1 is P implies not Q. Then we must place premise 2 in row 2, that is not Q implies R. We use the rules of inference to get the conclusion of these two statements. So we will get P implies R. We use law of syllogism. Then we place premise 3 in row 4. Premise 3 is not R. We use the rules of inference to find the conclusion of the statement in row 3 and row 4. So we will get a not P by using modus tollens. So this is the conclusion. It is raining.
Now I will present the rules of inference. What is the rules of inference? Rules of inference is a set of rules that can be used to determine the validity of an argument. The validity of an argument can be determined using a truth table, but if the argument has too many primitive statements, it will be tedious. Therefore, the rule of inference will be used instead. The rules of inference is when the hypothesis that is made up of a bunch of primitive premises that make a conclusion. So now let's try some fussy question. If Marisa comes to my house, then I will cook a red honey chicken. If I cook a red honey chicken, then I will bake the red velvet cake. If I bake the red velvet cake, then the meal will be complete. The meal is not complete. Write the primary proposition above using the variable P, Q, R, and S. So the variable P will be assigned to Marisa comes to my house. The variable Q will be assigned to I will cook a red honey chicken. The third one, R, will be I will bake the red velvet cake. The last one, S, will be the meal will be complete. The next question will be to write all the hypotheses or premises using in the variable in number 1. So the hypothesis can be made from each sentences. The first sentences is if Marisa comes to my house, then I will cook a red honey chicken. P imply Q. P is Marisa comes to my house, Q I will cook a red honey chicken. The second premise will be Q imply R. If I cook a red honey chicken, then I will bake the red velvet cake. The third premise will be R imply S. If I bake the red velvet cake, the meal will be complete. And the last premise is the last sentence, which is the meal is not complete, is not S. So now we need to find the conclusion for this argument. First, we take all of the previous premises. Then we choose the third one and the fourth one. And with this rules of inference, we can use the modus tollens. Now we took the second premise and the second sentence and the fifth sentence, and we can use the modus tollens yet again, and the conclusion will be not Q. Now we can use the first sentence and the sixth sentence, and we can use again the modus tollens. The conclusion will be not P. Therefore, Marisa didn't come to my house.